day 7. We're in day 7 of Algebra 2, guys. We've been doing all kinds of stuff in here, and y'all are really doing a good job. I'm actually very impressed with how far we've gotten in our content. Did you have your hand up? Okay, perfect. Let's look at number 1 together. So we have a quadratic expression here, and we want to factor it. So whenever we're factoring a quadratic expression, what is our answer going to look like? What's the format going to be like? So
A plus B.
Oh yeah, so we've got A. Are you talking about the ax squared plus bx plus c? Yeah, sure, let's write that out. Ax squared plus bx plus c. So that's our expression layout. When we factor a quadratic in the form ax squared plus bx plus c, what are the 2 parentheses that we have our answer in? What's the first term in those parentheses going to be? X. We don't have anything to multiply by. We just have x plus or minus something times x plus or minus something, because x times x will give us that x squared. So how are we going to figure out what goes in these parentheses again?
Factors 35.
Yeah, we're going to find the factors of 35. So let's see what those are.
35 and 5 times 7.
Good. 1 times 35 and 5 times 7.
5 times 12x.
Yeah. So
Plus 5x plus 7.
exactly. We want to make sure that these factors we found add up to our b, which is 12. Remember, our a is 1, our b is 12, and our c is 35. And 5 plus 7 does give us 12. So that means 5 and 7 are the numbers we'll put in our parentheses. So what's our answer?
1 plus 5 plus 7.
Good. X plus 5 times x plus 7. That is your answer. Good job, guys. Okay. Are we ready for number 2?
Yeah.
Yes. So we've got the same thing going on here. Our A is 1. Our B is 14. And our C is 45. So we'll start with the factors of C.
3 times 15, 5 times 9.
Good. So we could do 3 times 15, or we could do 5 times 9. You could also do 1 times 45, but I want my numbers to add up to B. And I know off the top of my head, 45 plus 1 is going to be much bigger than our B, which is 14. So I'm not going to waste space writing that. 9 plus 5, or 5 plus 9.
X plus 5.
Yeah.
X plus 9.
Yeah, 3 plus 15 is 18. That's not going to be our answer. 5 plus 9 is 14. And our B is 14. So that means these are going to be the numbers that go in our answer. So what is our full answer?
X plus 5, X plus 9.
Good. X plus 5 times x plus 9. And remember, with these, it doesn't matter which one is written first. You could have had x plus 9 times x plus 5. Same with the first problem. As long as you have a plus there and an x and they're in parentheses, your answer is correct. Any questions about numbers 1 and 2?
No.
Okay, let's move on to 3. Here's where it gets slightly different. This is a review of what we did yesterday. Now we have an expression where A is not 1. It's bigger than 1. So what's our A? 2. What's our B?
-10.
-10. What's our C? 8.
Find the greatest common factor.
Yeah, whenever A is not 1, it's bigger than 1, we need to find our greatest common factor first, which in this case is what?
It'll be
2.
5, -5, and 2.
Yeah. Let's divide everything by 2. And to keep track of my GCF, or my greatest common factor, I want to put it outside of parentheses and then write what all these terms are going to turn into when I divide them by 2. So let's start with our A term. What's 2 divided by 2?
1.
1. And 1x squared, we don't have to write the 1. We're just going to write x squared. Now let's look at negative 10 divided by 2. Negative 5. And we got to bring that x down. Now we have 8 divided by 2. 4. Good. So now we have a new quadratic expression where a does equal 1. And we know how to factor this. So what are our factors of our new c? Yeah, ooh, okay, so we have 1 and 4, 2 and 2, but we also want to think about, we need numbers that are going to add up to b. Our b is a negative number.
They need both be negative.
Yeah, let's use negative factors. Negative 1 and negative 4, when we add those together, that's going to give us the negative 5 we want. And negative 1 times negative 4 still gives us positive 4. We need to make sure that our factors are still multiplying to c, or 4 in this case. So since we know that negative 1 and negative 4 are the numbers we're going to use, what is our answer going to look like?
2.
Yeah, don't forget the GCF, 2. And then x. Uh-huh.
X negative 4.
Good. 2 times x minus 1 times x minus 4 is our answer. Good. So it's really just one extra step with these problems. We want to take out the GCF and just put it at the end, just like that. Before we go on and get too far ahead of ourselves, is anyone confused about number 3? Anybody feel like we want to talk about it at all, or are we ready to try another? Yes.
Positive 4, but I forgot that, when you're just subtracting it, it'll just turn into a negative pretty much.
So when you're subtracting which part, it'll turn into a negative?
With the 4, I just put the negative 1,
Uh-huh.
but like the 4 wasn't a negative, so I just put a positive 4 by her.
Yeah, so we know it needs to be negative, because if I did negative 1 times positive 4, I'd get negative 4. And we're trying to find the factors of positive 4, not negative 4. So that's where it's important to remember our negative rules for multiplication. 2 negative numbers multiplied make a positive. A positive and a negative, or a negative and a positive, those are going to give us a negative answer. So since we're looking for a positive answer in these factors, we want to have 2 negative numbers or 2 positive numbers. Does that make sense? Okay. Okay. Let's try number 4, guys. Similar problem. I've got 10x squared plus 50x plus 40. What's the GCF? 10. What's 10 divided by 10? I got x squared there. My 10 is gone. 50 divided by 10. Plus 5x. Good. 40 divided by 10. Plus 4. Okay, now what do I find the factors of?
4.
Factors of c, or 4. 1 and 4. I could write 2 and 2, but let's look at our b. Remember, our b is 5, and I want my numbers to add up to b. So 1 plus 4 is 5. Good. So I know my numbers I'll be using are 1 and 4. So what's my answer?
X plus 1.
Uh-huh. Good, 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 guys. Yes. It is a lot, but y'all are doing it. 10 times x plus 1 times x plus 4. Y'all got it. That's good. Questions on number 4? Is there any step of this process that anybody feels like they're starting to get maybe stuck on? I don't want anybody to feel like they're stuck on something and they're nervous to ask, how to do it or nervous to ask for help just because most of the class seems to be getting it. I don't want you to feel like you need to stay quiet and be left behind. I want you to speak up if you're feeling confused. And if you don't want to speak in front of the class, come and find me later. I promise I want to sit with you and make sure you do feel good about this. Okay. We want to do number 5? Okay. Yeah.
Because I didn't even start that with somebody, right?
That's all right. 6 is going to be kind of what we're learning about today. No.
What would be emerging into algebra 2? Are we
Probably nearing the end of next week, we'll start getting into that real algebra 2 content. We're kind of finishing up that 1B right now. But we're getting there. We're getting closer. I think you guys are not going to struggle with it at all. You are doing so good. Okay, guys, are we still looking at 4? I hear a few conversations. People are talking about some of these problems. Are we still looking at 4? You guys good? Okay. Oh, you're okay. If we want, I mean, seriously, I bet you even if we all feel like we got this, there is never going to be any hurt with reviewing it again. You know, nothing ever hurts reviewing it again. If there's anything you're confused about, we can talk about it. Unless you would rather just wait and do it later.
I'm slowly making sense of it.
Okay.
But I get it. I'm not that lost.
Okay, awesome. Good. All right, let's start number 5 then, guys. What's my first step? Yeah, I want to get my A to 1. So let's divide everything by 3. And what does this become?
1, 4, 2.
My A is 1, so I've got x squared minus 12 divided by 3 is 4x. 9 divided by 3 is 3. There we go. Okay, what am I finding factors of?
3.
Of 3.
So you do -1, -3.
Ooh, yeah. So since our B is negative, we have a -4. If I do my positive factors of 1 and 3, which is, my factors of 3, which is 1 and 3, 2 positive numbers will never add together to make a negative number. So we need to do the negative factors. -1, -3. When we multiply those, we still get +3. But when we add them, we'll get that -4 we need. Okay, equals -4. So these are the numbers we'll use, -1 and -3. What's our answer going to be?
3.
Here. X
minus 3.
3.
X minus 1.
X minus 1. And you could put these in either order. Could be x minus 1 and x minus 3, or the way I wrote it. Both are correct.
Oh, number 6, you can't do that.
Nope. Number 6 is where it gets real tricky.
Let's do this.
Okay, guys.
I don't know if I did it right.
Any questions about number 5 before we go on to 6? You guys ready for the challenge?
Yes.
Okay. First of all, who attempted it? Who tried it? Okay, you did. Okay, a few of us did. Do any of you feel like you got the right answer? I love the confidence. Nope. Okay, some of us think we got it. Let's see if we do. I'm going to actually flip my page over because I want to give myself lots of space for this one. And we're going to go through it slowly, very slowly. So I'm going to write 3x squared plus 11x plus 6. That's my problem. So number 6 was 3x squared plus 11x. Thank you, plus 6. Okay. So first step. Normally we would want to check for GCF. Is there any number that I can divide all these by? No, there's not. So say it again. Because of the 11, exactly. I could divide 3 by 3. I can divide 6 by 3. I can't divide 11 by 3. So that means I don't have the ability to write a GCF out to the side and turn it into x squared by itself. I'm going to have to do something different for my answer. Yes, yes. So whenever we have a quadratic expression with x squared as the leading term, we know that we can factor it into an answer that looks like this. We have x plus or minus something times x plus or minus something. But in this case, we have 3x squared, and we can't reduce it. So our a, exactly like you said, Mac, our a, which is 3, needs to be in our answer so that when we multiply out these little binomials we're going to come up with, we're going to get 3x squared. So let's just put 3x here and then make the other one x. Yeah. Now, before we move on, though, does anybody feel confused about why I put a 3x and an x?
Yeah.
Okay, let's talk about it. Let's talk about it. So, whenever we are multiplying binomials, remember that's when we were doing the FOIL method or the box method, we're always going to come up with an answer. For example, I'm going to write my x, I'm going to do like x plus 3, x minus 3, for example. Okay. X times x is x squared. My outer x times negative 3 is minus 3x. And then 3x plus 3x. And then 3 times negative 3 is negative 9. Okay, so basically what's going to happen is you're going to end up having an answer with x squared plus something x plus your c. That's not what we want the factor of. We're trying to find the factors of this problem where we have 3x squared. So to get an answer that has 3x squared in it, we need our first terms to multiply to 3x squared. So like when I FOIL or do the box method, 3x times x equals 3x squared. And then it'll be plus something x plus c. Does that make a little more sense? So when we factor anything, we're just finding the two things that we multiply together to make that number, the two numbers.
Plus, wait, you get 3x plus 2
I don't know. We're going to find out here in just a minute.
after you do your table.
Yeah, we got to do our table first.
Where did where did the square, like, because it's 3x squared, and
Uh-huh.
you said up there is 3x plus multiply x, it makes it 3x squared, but
Yes.
where did the square already go? Because it wasn't
Your
already
x's.
3x squared.
Your x is on
So,
the
3x times x gives us 3x squared, because when I do, let's ignore the 3. X times x is x squared, or any number times itself is that number squared. Like if I did 2 times 2, that could also be written as 2 squared. So if I had x times x, we could also have that written as x squared. So all we're doing is just adding a 3 onto it. So like if I had 3 x's and I multiplied it by x, that's going to give me a total of 3x squared. And the goal of factoring something is finding the two numbers or the two terms that I can multiply together to get this whole expression. Just like when I'm finding factors of 6, I'm doing like 1 and 6, because 1 times 6 makes 6. 2 and 3, because 2 times 3 makes 6. So here, we're trying to find what times what makes 3x squared plus 11x plus 6. It's just a much more complicated version of finding factors of a regular number. And I think as we move through it, it'll click more and more. I think sometimes whenever we do these problems, the first couple of tries aren't going to make a lot of sense. Those patterns will start to click as we get through. So let's just keep going. And I think it's going to start clicking. So because we have 3x squared instead of just x squared, my answer needs to be 3x, bless you, plus or minus something, times x, plus or minus something. So this is my answer format. Now we're going to do everything like we normally would. And here's what I mean by that. My A is 3, my B is 11, and my C is 6. So we are now going to find all the factors of 6. Yeah. So let's list out all the possibilities. And our B is positive. So do we need any negative factors? No. So let's just talk about the positive ones.
1 and 6.
1 and 6.
6 and 1.
6 and 1.
2 and 3.
2 and 3.
3 and 2.
3 and 2. There's no other possibilities. We're just going to use, we've got 4 options now. So now that we have these, because our A is 3, when we add our factors together, we're not going to get any of these adding up to 11, our B. So this is where the trial and error starts. And I'll show you what I mean. We have 4 possible answers here. We could have 3x plus 1 times x plus 6. Let's try this one and see if it works. So before we go out and write all 4 options, we're going to try each one as we go. So we're trying this first. So here's where I like to do what I call it the rainbow method, because it's like I'm making a little rainbow with my numbers. And I'm going to do it underneath because I don't have a lot of room here. I'm just going to try taking 3x times 6. And what's that going to give me? 6 times 3, that's 18x. And right, 1 times x is 1x. And 18x plus 1x is 19x. What I'm looking for here now is, does this match my middle term? 11x. It does not match. 19x is too big. So that means this is not the answer. And we move on and try another one. Yeah. So we just worked with 1 and 6. This is where sometimes it's a game of luck. But the more you do it, the more you start to recognize in your head what numbers will and won't work right away. So let's try, I don't know, 3 and 2 for fun. Let's do that. For fun. I'm going to write out again 3x plus or minus something times x plus or minus something. And we said we're going to try 3 and 2 this time. So plus 3 plus 2. So we're going to do the rainbow method again. And if you would rather not do this method, that's fine. You could also just do this part in your head. I just like to label things and I like to draw pictures. So that's what I'm going to do.
That makes it make more sense.
Yeah. So I can show you what I'm connecting here. 3x times 2 is what? 6x. And then what's 3 times x? 3x. 6 plus 3 is 9x. Oh, that one didn't work either.
Try 2 and 3.
Okay, so that's not an answer. Yeah, let's try 2 and 3 now. So again, this is where there's a lot of trial and error. We get really good at it the more we do it. Let's put our 3x and our x again. And this time, so we just did 3 and 2. Let's try 2 and 3. Yeah, I'm going to draw my rainbow. 3 times 3, 9x.
2 times x.
2 times, 2x. 9, 10, 11. Ooh, 11x. That's the same as the middle term in our original expression. 11x. So because they match, this is our answer. 3x plus 2 times x plus 3. So what this tells us here is whenever I multiply these binomials, just like we learned at the very beginning of Algebra 2, if I multiply these using FOIL or the box method, I'm going to come up with this as my answer, 3x squared plus 11x plus 6. If your factors don't multiply to your original expression, then your factors are not correct. They need to multiply to get the original expression. Would it help anybody to see what happens when I multiply these together, how we check that answer? Sure? Okay, let's do it. So let's do it. I'm going to write it a little lower. 3x plus 2 times x plus 3. So we've been doing a lot of foiling. Do a little box method. Either one you could do. I'll show both. So in this case, I would have, let me zoom in for everybody so we can see a little better. 3x plus 2 and x plus 3. What is 3x times x?
3x squared.
Good, 3x squared. What is 2 times x? 2x. What's 3x times 3?
9x.
Good, 9x. And then 3 times 2?
6.
6. And when we combine our like terms in the middle,
It'll be 11.
it'll be 11x.
Oh,
And look at this. I got 3x squared plus 11x plus 6. And look at that, guys. If you check back, that's the same as the original problem, 3x squared plus 11x plus 6. That's what we're doing when we're factoring. We're figuring out what binomials do I multiply together to get this. It's the same thing. It just takes a lot longer.
So is there a good way to look at it, like, because it doesn't have a greatest common factor?
Yeah.
Just drop that number
Yes.
down into the
Yes.
parentheses. That's how I
Yes.
look at it. Because the other way, it makes it more difficult
Right.
to comprehend. So just
Right.
drop that number down into the parentheses.
Exactly.
Where you don't have a common factor.
So I'm going to explain that again. That's a great way to think of it. Whenever you are checking for your greatest common factor and there is none, or if you found a greatest common factor but you still have a number for A, you want to drop that number down into your first parentheses. That's all you'll do is just carry it down. And then you do the guess and check part. Okay. Who got this right? Get it. Come on, guys. Good job. If you didn't get it right, don't worry. Don't worry. This was just me showing it to you. We are now going to go in depth and make sure everyone has a good understanding of what just happened and how to do this on your own. Okay? So here's what we're going to do next. I'll leave this up here for a second in case anyone's looking at it. I have made worksheets. Lots of practice problems, guys. A big worksheet where all of the problems have A that is bigger than 1, and there is not a greatest common factor that is A. When I say that, I mean we can't divide by a number to get this down to x squared. We're going to have a number for A, and we're going to have to put it in our answer and do trial and error. Okay? So I'm going to pause this and pass these out to you. And we're going to go through some of these together first before we have practice time. Pause it. And before we start on this worksheet, this is optional. I'm going to do this because you guys have maybe noticed I'm notorious for losing things. I'm going to label this paper day 7 because that's today, just because I want to remember that day 7 is when we did this. And I'm also going to write the date. It is Wednesday, November, is it 5th or 6th? 6th. Wednesday, November 6th.
And it's also Steph's birthday.
Happy birthday! Oh my goodness, that's exciting. Well, I appreciate you showing up on your birthday. Not everybody would.
Yeah.
I love it. Well, happy birthday.
I'm gonna say you look really, really good.
Aw, I love it. I love it. All right, guys. Let's look at number 1. So let's start slowly.
Yeah.
We are going to label our A, our B, and our C. So what's our A here?
10x squared.
10. B, what's our B? 12. What's our C? 5. Is there a greatest common factor here? No, I can't divide all of these by the same number. So there's no greatest common factor. So because I can't factor anything out, I know that my answer is probably going to have 10x first times x here. So
That's
here's
what I was asking earlier, is that why are we changing it just to 10x and not keeping the square?
Because your x's are gonna separate common.
good question. So if I put like 10x squared and a x squared, when I multiply them, it would become 10x to the 4th power. And we want our answer to, like when we multiply these factors we come up with, they need to come up to 10x squared as the beginning term. But if I had, like a 2 here and a 2 here, it would turn it into a 4.
Yeah.
Square equals 1.
I was
Yeah.
just wondering how we did that, like why there was one off.
Yes. No, that's a great question. I'm sorry I didn't understand that earlier.
I know everybody was like, oh, we're going through this again, but I was like,
No, that's my bad. My bad. I just didn't get it. Awesome. I'm glad that makes sense now. Okay. So here's what we're probably going to have our answer looking like. So what should we be checking now? Factors of C, or 5. Let's see what they are. 1 and 5, or 5 and 1. Okay. So we've got some options here that we need to try. Let's try 10x plus 1 and x plus 5 and see if that works. Okay, let's see. We're going to get 50x. We already know that's too big. It needs to be 12x. So yeah, 50x plus 1x is 51x. That's a no-go. Let's try the other one. And if it doesn't work, then we go even further to another step I'll tell you about.
Yeah, that's the problem.
We got all kinds of problems in here. So 10x and x, and then we'll try 5 and 1.
We get 15 in.
Okay, yeah, let's see. Some of you are getting this pretty quickly, and that's great. Just want to make sure we're going slow enough for everybody to follow. So 10x, yep, that's 10x, and then 5x. Oh, we got 15x. And it needs to be 12x.
Next step.
Ooh, so we can't use either of these. Let's talk about, it won't be a negative, because if I had 2 negative numbers here, you would be able to multiply it to positive 5, but I cannot add 2 negative numbers and get a positive answer for B. So here's where I'm going to pull out another piece of paper because there's not enough room on here. So let me grab another sheet of paper real quick. And if anybody else needs sheets of paper, up here, I moved the turn-in tray so that I would have room to station myself since the camera is still being laggy. So I got to have it hooked up with a wire instead of wirelessly. But I'm going to grab a paper for myself. And let's look at this problem. I'm going to zoom out a little. So let's do this. We're still on number 1. So for number 1, I'm going to rewrite the problem just so I don't lose track of it. 10x squared plus 12x plus 5. And we just tried all the possibilities for factors with 10x and x. So I know that that's not going to be what's in my parentheses now. So back to where we were. If I can't do 10x and x, I tried all my factors of 5. It didn't work no matter what I did. That means we're going to need to break this 10x squared down even further. We're going to find the factors of 10x squared here. So in the first try, we did 10 and 1. You didn't even know it, but we were factoring 10x squared here because 10x times 1x makes 10x squared. What are 2 other numbers that we could try? 5 and 2. Yeah. So I could do 5x times 2x. 5x times 2x gives me 10x squared. So why don't we try making those the first terms in our answer? We'll do 5x and 2x. So this is where that trial and error starts to happen. So now we've got different leading terms in our factored answers. So all we need to do, we don't have to go back and find the factors of c again. We've already got that. Let's keep trying again. Now let's try putting 1 and 5 into these. 5x and 2x. So we'll try 5x plus 1 and 2x plus 5. And let's check it and see if when we do our rainbow or when we multiply our inner and outer terms, let's see if we get 12x. That's what we want. Yep, so 5x times 5 is 25x. I already know it's too big. 1 times 2x is 2x. I'm going to get 27x. Oh, man. So that one's also not going to work. It's also not going to work. Let's keep trying. We've still got 5 and 1 instead of 1 and 5. So now I'm going to write 5x plus 5 and 2x plus 1. And let's hope and pray that this does it. Let's see. 5 times 2. Oh, 2x, that's going to be 10x. 5x times 1 is 5x. So we're going to get 15x. That's still not 12x. Switch what now?
5 and 1.
5 and 2. Can you do that? Does that make sense?
You mean put 2x first and then 5x?
Yes.
So we could, but we already did all of those answers. When we put the 1 and the 5 here, so I've got 5x plus 1, and I've also got 2x plus 1, and I've got 5x plus 5, and I've got 2x plus 5. I think we've exhausted all of our options here, haven't we? The answer is what? 0? Which part of the answer is 0?
No, the whole
The whole answer? It's 0. Huh, let's see. Does anybody have any other ideas for what we could try maybe?
No.
I know, it gets crazy, doesn't it? Got a lot of trial and error here. What do we think, guys?
Could we divide the 10 instead by 5?
So, like, factor out a 5 here?
Yeah.
Well, 12's not divisible by 5. So we couldn't do that, could we? So 12 is divisible by 6, but 5 and 10 aren't. So we can't do that. This might be an example. No, because 5 isn't divisible by 2. This might be an... Say it again.
Would it just be by something, not just by 1 or something?
By 1? You mean...
I mean, yeah, like it can't be anything else.
Can't be factored?
Yeah, so just be 1.
So this might be one of our unfactorable problems.
You said 0.
0. So we've exhausted everything. We have. Because we tried 10 and 1. We tried 5 and 2. We also did 2 and 5, because if I show you this, look, if I do 2x and 5x, yeah, then I would have, I don't know, maybe we need to try the negative factors of 5. Let's see. What if we try that? You never know, maybe we'll come up with the answer. Let's try negative 1 and 5 and see what happens. So maybe we'll do -1 plus 5. We'll see what happens here. Okay. -1 times 5x is negative 5x. 2x times 5 is 10x. Okay. So that's going to give us 5x, but we need 12. So that's not it either. Why don't we try switching to +1 and -5? Why not? Let's try that. 2x plus 1, 5x minus 5. Hopefully this one will work. Let's try. 1 times 5x is 5x. 2x times -5 is -10x. No, that's just going to give us -5x. Should we try the negative factors with 10 and 1? Maybe we moved on too quick. Yeah, absolutely. I know. So one of the big things that I want us to take away from this process today is learning perseverance in your math problems. And when I say perseverance, I mean even when you feel like you're stuck, to just keep going and keep trying different methods until we do find that answer, because there's got to be a way that we can do this. There's got to be a way. No, I looked for it during lunch, but we'll make it. We could take some notes after this, yeah. Let's see. Okay, I'm going to write over to the side my 10 and 1 again, and maybe we'll try the negative factors there. And you guys, while we're trying this is a whole process. It's okay if you're not copying every little bit down just yet. So our factors, we're actually not, I don't think we're going to be able to do this. I really don't.
At this point, it seems like we're just riding the same.
Yeah. I think that this is not going to be factorable.
I went ahead and took the quadratic equation.
That's where I'm thinking we're going to have to go with this.
I was going to tell you there's no real solution.
Oh, they gave us a trick problem.
As the first one.
Are you kidding me? Come on. Okay, guys. Well, you know, that's frustrating. Number one doesn't exist, sadly. And you know what?
So long on it.
I know, we did spend so long on it, but that's okay, because sometimes we're going to have things like that happen, and I don't want anybody to be worried that a problem like this will ever negatively affect your grade. For example, if we have a problem that like comes up and it's this type of thing where we can't really factor it, and even when we do use that formula, which we haven't learned yet, you're not going to get a solution. I will see that when we're going through and I'm grading. That will not go against you guys. So don't be worried. This one was a very bad example. A very bad example. Well, I'm sorry about that, guys. I thought that was going to be a good one. Maybe I need to make sure these are good, because I would hate it for all of them to be like that. That would not be fun. I know. I felt so good about this worksheet too. Let's see. Yeah. Okay. For now, let's set this worksheet to the side, because I don't want to give you problems until I've gone through and solved every single one and I know we can get solutions. I thought that I could just trust, like, oh yeah, this worksheet will give me, this must be a worksheet where we need to use the quadratic formula, which we have not learned, and I don't want to introduce to you just yet, because we're learning a lot of new things, and I don't want to add one more to the mix before we feel great about this.
Especially that guardian.
Yes, my goodness. So I'm going to be the first to say I apologize. I should have checked that before I gave it to you. So put it to the side for now.
I'm not going to go and watch the video, because I think watching how something doesn't work out is going to help you figure out how it does work out, because I was lost until you said that it wasn't solvable, and then I was like, okay, so we're not getting it wrong, we're just not going to be able to get it at all.
Right. So, Stephanie, I appreciate you saying that, because, you know, sometimes when I make mistakes, you know, I'm a human. I get down on myself. I'm like, God, Taylor, why did I not check those before I taught it? And it's like, you know what? Maybe this is helping someone. Even if it's frustrating, it helped you today. So that's good. And I appreciate you saying that. So let's start a page of notes. This is how I titled my notes. Day 7, continued. And I have a list of expressions that I know will work. I thought I would just jump straight to the worksheet, but you know, we're not going to do that anymore. Let me grab that list. Okay. Here's this. Here's that. And let me pause this real quick.
Were there notes yesterday?
Back to it. Scratch everything we just did. Here's a problem for us. Let's do 2x squared plus 7x plus 3. And I want us to go very slowly. I want us to take our time and understand every little step, understand why we're writing anything on our paper. I don't ever want you to write something on your paper unless you get it. So, first thing to do here, let's identify our A, our B, and our C. What's our A here?
2x squared.
2. So our leading term is 2x squared, but our A is just 2, just 2. Our B is what? 7. And our C is 3. Is there a greatest common factor? Nope, there's not. So that means, yeah, that means 2, or A, is going to be in our answer. So I'm going to need 2x plus or minus something times x plus or minus something. Here we go. And I'll give everybody a moment to get to that point. And since this is a newer topic, let's make this into a guide like I said we would earlier. I'm going to make a little note to the side. If you already understand this, don't feel like you have to write this part, but I'm going to write it for those that it will help. I'm going to say A is greater than 1. And there is no GCF. Oh, hang on. There we go. Our A is greater than 1 and there's no GCF. So, instead of x and x, we put A, or our 2, in the first parentheses. Like this, 2x and x. Okay, here we go. We're doing factors of C. So what are some numbers we could multiply together to get C?
1 times 3, 3 times 1.
Good. 1 times 3 and 3 times 1. So all we need to do now is check and see which one of these are going to work. So let's start with plus 1 and plus 3. Let's find it. And here is where we'll do the rainbow. My outside terms I multiply. My inside terms I multiply. And I want it to be 7x. So 2x times 3 is 6x. 1 times x is 1x. 6x plus 1x is 7x. Yes. It's right. So this is our answer. Oh, that's so much less stressful. Oh, I'm so sorry about that, guys. That's our answer. So the only difference here is you're going to have your A in your answer. If you can't get rid of A, it goes in your parentheses. So I'll give everybody a moment to write that. And as you're writing it, sometimes those questions or confused moments come later. Maybe you're not writing as I'm speaking, and that's okay. So I want to give everybody a moment to look at this, think about it, and tell me if there's anything that you're confused about while we're finishing writing it. And maybe we don't have questions yet. Yes?
So like, what does the in red part really mean?
So what I'm saying here is I'm talking about our quadratic expression layout, which is ax squared, 2x squared, plus bx, plus 7x, plus c, plus 3. And I'm saying that whenever my a is bigger than 1, and in this case it's 2, and I'm not able to get rid of that 2. I'm not able to put it outside of parentheses, divide every number by 2, and then get a equals 1, then I'm going to have to put a in my answer. So that when I multiply and FOIL, because remember, whatever we get as our factor, we know it's correct if I can take 2x times x and get 2x squared. Then my outer terms, which would be 6x plus 1x is 7x. And then 1 times 3 is 3. So that would be correct here. If I can't do that, it's wrong.
Okay, so there's no GCF if
Yes.
you can't divide.
Yes, there's no GCF if you cannot divide every number by something. Or every term by something. Yeah, thank you for asking that. Any other questions we might have? If not, we're going to do another one. Say it again.
For the people that are at home and I'm gonna watch this.
Yes. So, write what no GCF means? Okay, let's do that. So, over to the side.
What you have to do is very.
Yeah. No GCF means we can't divide every term by the same number. Sorry, that's really small. So underneath that in red, that's what no GCF means. And then after that it says, so instead of x and x in your parentheses for your factored answer, we're going to put a or 2 in the first parentheses right here. So it's all written out. If you want to copy that down, feel free. Because I know this is tricky stuff. It's good to have a key to look back at so you don't feel like you got to memorize it. So there is an example of that. Okay. Anybody still need a moment to write? You guys want to try another one? Okay, let's do another one. I'm going to move on. Number 2. This time we'll do 4x squared plus 9x plus 2. So first of all, what's our A, B, and C?
4, 9, and 2.
Good. A is 4, B is 9, C is 2. Now, I'm going to write it even clearer. Again, if you feel like you get this, you do not have to write any notes that I put to the side, but if you think it's going to help or you know it's going to help, do it. I write all kinds of notes because I have a very forgetful brain. So step 1, check for GCF. Can I divide every term by a number? No. Whenever I'm checking for GCF, I feel like my first guess is 2. I always just guess, I'll see if I can divide them by 2. I can do 4 divided by 2. 9 divided by 2 is going to give me a decimal, so I can't do 2. 3, well, my smallest number here is 2. So I can't do it. There's no GCF here. Yes, so since there's no GCF, we need to put A in the first parentheses. So I will put that as a note as well. Yeah. So these are great guides to give yourself, just like you said, for whenever we do take like quizzes and stuff. You guys can use your notes to solve problems. So it might be nice for you to have a guide like this to look back at. So since there is no GCF, A, or 4, needs to be in my answer. So I'm going to go ahead and put down here 4x and x. Okay, does everybody see how we got to that point? Yay.
Oh, yes.
Good deal. Okay, so that's step 1. Now let's go to step 2. Step 2, we want to list all factors of C, which in this case is 2. And then we want to try putting them into our answer. So, what are the possible factors of 2?
1, 2, 2, and 1.
Yeah, 1 and 2, or 2 and 1. So I'm going to write that over kind of to the side here. Factors of 2, 1 and 2, or 2 and 1.
2 and 1.
You said 2 and 1's probably going to, we can try that first, absolutely. Doesn't matter which one you try first. Sometimes it's a game of luck, you know, if you decide, I don't know, for fun, I'm going to put the 2 first and see. But the more we do problems like this, you'll actually start to notice it becomes a mental thing. You'll start to be able to recognize that you're trying to get your number in the middle to be this B, 9x here. So you'll start to say like, okay, well if I put, 1 over here, 4 times 1 is 4, and a 2 here, then I'll have 2.
1 and 2, minus 1, and then minus 2 is the positive, right? Plus 1.
Well,
Plus.
let's try plus. So let's try this first. My 1 and 2. Plus 1, plus 2. Okay, so I put it in, and I'm going to say, this is kind of step 3. And this is where we do what I've been calling the rainbow method. Rainbow. And I'll explain what that means in this step here, so that when you look back at your notes and see rainbow method, you're not confused. Okay. So 4x plus 1, x plus 2. So what I'm doing is I'm multiplying the inner terms and the outer terms. We're just doing the OI part of FOIL, OI. multiply inner slash outer terms. And add them together. Oh, sorry guys, I'm not even showing my paper. To see if their sum is 9x, because that's our middle term. Okay, I'm going to stop for a second. Slow it down. I feel like I'm giving you lots of things to write, and I don't want anybody to get exhausted. So let's check these. Okay, I'm going to go ahead and draw my little rainbow over here. I'm going to be multiplying 4x times 2. What's that? Yes, 4x times 2 is 8x. And what's 1 times x?
1.
Good. 1x. And would you look at that, guys? 8x plus 1x is 9x. And that's our middle term, 9x. So, what does this tell us?
It's correct.
It's correct. This is our answer. We got lucky. We picked the right one the first time. So we circle it. I'm going to circle it, and then I'm going to wait. I see that many of you are still writing, and I don't want to move on while you're in the middle of writing. Let me give everybody a moment to catch up. Anybody still need notes for number 2? If you do, that's fine. Anybody still writing? Okay, before we move on to another one, is there anything that we want to talk about with number 2 now? Any questions we have? Any confusions? Somebody said something. Who just talked?
I just asked for a highlight.
Oh, okay. Gotcha. Okay. Do we want to try another one? Yes. Okay. All right. I'm going to move this to the side. This will be the third one today. So, I'm going to label the top of my paper. Day 7. Same thing that we've just been doing, where I've been giving you problems, and we're kind of taking notes, I guess. I guess these are notes. So I'm just going to title this Day 7 Continue, just the papers that I'm writing in front of you. Okay. And this is page 3 for me. Here's another one. Let's try 5x squared plus 13x plus 6. So we want to factor this. If I look back at the guide that I made, on the last page. Step 1 is to check for GCF. Can I divide
No.
every term by a number? No, I can't. I cannot. So, what do I do?
Drop down A.
Yeah, I need to bring my A term, or my 5, down into my answer. So, I'm going to have two sets of parentheses where one begins with 5x and one begins with x. Okay, so we completed step 1 there. Our 5 is in our answer. What should we do in step 2? Yeah, for step 2, we want to look at all the factors of C. In this case, our C is 6. Good. So I'm going to bring this over here. 6. We've got quite a few this time. Yeah, we've got 1 and 6, 2 and 3, 3 and 2. Can't do 4, can't do 5, 6 and 1. And that's it. That's all our factors. So, we got our factors listed out. The other part of step 2 says that we need to try putting them into our answer. So, now it's trial and error time. And we're going to be using the rainbow method here. Unless you do it in your head, then that's great, wonderful. Me personally, I got to write it out because I'm going to mess it up if I do it in my head. So, we will try, you want to try 6 and 1 first? Okay, let's try that. Plus 6 plus 1. So yeah, whenever you've got a bunch of different factors, you don't have to necessarily do them all down the line. You can choose to try different ones first if you'd like. So we're going to do 6 and 1 first. Okay, now let's make our rainbow. 5x times 1 is 5x. 6 times x is 6x. 5 plus 6 is 11x. So it's not that one. Try which ones? 3 and 2? So we can't do a negative number and a positive number because we're trying to factor a positive number here. So our factors have to have the same sign. But if we have both negative numbers, then our middle term is going to be negative, and we need a positive middle term. So we know we're going to only be working with positive numbers.
Positive 3 and 2.
Yeah, I heard a couple people shout that one out. Let's try positive 3 and 2. I know that one didn't work. I'm going to cross it off. Let's try this one now. Oh, let's see. I bet you might be right. So 5x plus 3 and x plus 2. So I'm going to rainbow it. 5x times 2, 10x, and 3 times x. That gives me 13x. So, that one's right. What does that tell us? It tells us this is our answer. We have factored it successfully. This is our answer. This is our answer. So we circle it. Does anybody confused about how this is our answer? Do we want to see the process of how we can turn our answer back into the original expression? Would that help anybody? It wouldn't hurt. Okay, well let me show you how to check your answer. Let's say you get this, but you just don't feel good about it. Like you're like, okay, I know that I got 13x, but I don't understand why that means it's my answer. Let me tell you. Let's look. So here's my factored form, and if you get it and you think that this is going to confuse you, you can zone out for a moment. But I'm just going to explain how we know that this is the factored form. So I am going to write it out again. 5x plus 3, x plus 2, and would we like to do the FOIL method or the box method? FOIL. Let's try FOIL this time then. So I'm going to do my first terms. 5x times x is 5x squared. My outer terms, 5x times 2 is 10x. My inner, 3x. And my last, plus 6. When I combine these like terms, I get 5x squared plus 13x plus 6. And look, that's the same as my original expression. So I know that 5x plus 3 times x plus 2 is 5x squared plus 13x plus 6. That's right. That's right. Good stuff, guys. Okay. Let's see. Now, go ahead. I'm going to leave this up here for a moment. I'm going to pause this recording and I'm going to grab a list of some other problems that I'm going to have you guys try on your own for a moment. Okay, one more example together. Or you know what? Instead of doing this one together, I'm sorry guys. I'm going to say today, number 6, this will be your exit ticket. If you feel good about it, go ahead. If you don't, I'm going to come around and be available to work with you one-on-one, get you feeling good about it, okay? And we'll get to a good point where we feel good. This is going to be our exit ticket today.
You want to do it on separate?
Up to you. If you want to keep it on your worksheet, that's fine. If you want to put it on a separate paper, give yourself more room, that's also fine. I'm fine with either. Exit ticket, this is day 7. Okay. Alright guys, tomorrow I will be more organized, I promise. I thought I was being organized today too. I was feeling really good about it. I'll be losing stuff. Okay, I'm going to end that here and I'm going to come around and see who needs help.